Hello, folks of Earth Space. Here we go with a little Unit 1 final project guide. So I'm going to walk you through a little bit of this idea of the Front Range geology and give you a little bit of history of how it formed, let you in on some of the names and the composition of some of the layers that exist. And then it's going to be your job to try and see if you can explain how all of this happened. Like, what was the timeline? What was going on when some of these different layers were formed? And how did they go from being flat to angled? And just all kinds of weird things that took place. Lots of observation and inference stuff here going on, as with a lot of geology, because it's so old and it happened so long ago that we have to rely on the idea of inference along with our observation. So I'm going to walk you through some stuff, and then we're going to go from there. All right, so this summer I was very fortunate to be able to take a class at CU, Geohabits of Mind, learn a little bit more about geology. And one of the first things we did was actually on the first day we met at NCAR, and we took a little hike, and our hike kind of took us from right behind NCAR right here. We walked and kind of followed a little trail that took us up here, and then we ended up right around this area in some of this fountain formation stuff right here. We didn't quite get up into the Precambrian rocks. This is some of the stuff that's more igneous rocks, so we didn't quite get up to that. We saw some of the boulders that had come down from it, but we ended up ending in this fountain formation area right here. And so we went across a ton of different types of material. Now, if you didn't know what you were looking for, which I didn't until I actually took this hike, I wouldn't have even put it together that some of the rocks that we saw were actually parts of much larger layers that go all across the Front Range. They're not just in Boulder. They go all the way down, even into different states. You can find similar rocks to what we have here in the Front Range of Colorado. Now, this is an aerial view. This is what it would look like if all of these were exposed and didn't have a bunch of sediment on top of them. This is what we might be able to see in these different types of layers. And they are actually, in some cases, different colors. If you ever have a chance to take that hike, you can kind of check it out. Okay, now, this particular video, I'm not going to play here and make this part of my screencast, but I would strongly advise that if you have not seen this video, I got to do this in one class, but not the other. So fourth period, you in particular are going to want to watch this video. It just talks about how the Rocky Mountains were formed. The Rocky Mountains are a little bit weird, right? Because most mountain ranges that we looked at in terms of plate tectonics and plate boundaries occur right at the border, right? So something weird had to have happened in order to be able to get a mountain range so far inland, so far away from the border of the Pacific and the North American plates. And so this just kind of walks you through that a little bit. Now, this process, the last part of this, the last big upheaval of the Rocky Mountains occurred about 40 to 70 million years ago, which is way after all the layers of sedimentary rock had been put down in the North American continent. And so, there was just a ton of these layers, and sedimentary layers tend to be horizontal because of the way that they're formed when they go through that whole process of, the 5 steps to forming sedimentary rocks. Well, gravity is going to pull them down and they're going to be laid pretty much flat. And so for these to be angled is a little bit weird, and it's because of the formation of the Rocky Mountains and the fact that it happened after all these other layers had been formed. So all of that stuff that you saw, which was vertical from the aerial view, this is what it would look like if we could kind of get a cutaway version of this. So imagine that we had to go ahead and try and figure out relative ages of these guys and say which one was oldest and which one was youngest. Well, knowing that these Precambrian rocks, which were part of the igneous rock that was underneath all of the rest of this, got pushed up with the formation of the Rocky Mountains, it basically took all of these layers and went ahead and turned them on their side. And so if we were looking oldest to youngest, we'd go to the fountain formation. So if this was horizontal, this would be on the bottom, and the Pierre Shale would be on the top. And the law of superposition tells us that the ones that are on the bottom are older, right? And then you just kind of move upwards. And we'd have to be able to try and figure out when the faults occurred and stuff like that. So fountain formation, oldest, Pierre Shale, youngest. Now, here's something that's really cool about the Pierre Shale. The Pierre Shale, some of it was actually deposited Some of it was actually deposited after some of the Rocky Mountains were formed. And this stuff was like a mile thick. And so much of that has been eroded over time to be able to allow us to go ahead and see a bunch of the stuff that's here. And the Pierre Shale is essentially what most of the Front Range, Boulder, Lafayette, stuff like that, is standing on. So, your house sits essentially on top of the Pierre Shale if you live anywhere here on this Front Range. So you can see how these would have been flat, and then Precambrian, boom, big upheaval pushes everything sideways. There you go. Now, when you're on this hike, this really isn't what you see, right? You don't see these guys. There's a bunch of other material that's on top of here. You got vegetation, you got all kinds of stuff that doesn't allow you to be able to just all of a sudden be walking along and go from, oh, I'm on this part, and now I'm on this part, and they're different colors and they look different. You have to really know what you're looking for. Now, Mr. Mattis put this together. He took the class with me as well. So he took this picture, and along with some help from one of our teachers that helped lead us on this little class that we took, he was able to help us identify where some of these different layers would show up. So you can see, right, here's a bunch of soil and stuff that's on top of this, but you can see through some of the trees what we call rock outcroppings. And these rock outcroppings are what you use to identify where one layer ends and the next one begins. And so if you're far away, you can really kind of see where they're at, because if they're rock, you're not going to have as dense vegetation in there because you don't have the weathered material that can support plant growth. And so you can kind of see some of these as you go through. Now, here's what a rock outcropping would look like. As you're walking along on a path that's nice and, beat down and stuff like that, and all of a sudden you come across and you look and you're like, oh, wow, that's really weird. Here's a bunch of these rocks that look very similar. And so this is some shale. And I don't remember if this is from the Pierre or the Niobrara Formation, but regardless, you have evidence that there is this layer of this rock that doesn't match a lot of the surrounding material. And so this is an observation that geologists would make. They'd look to see if they could find something that they could use to date it, some kind of fossil or something like that. And then they'd look to see if they could find similar rock in other areas. And when you're walking on this path, you can really tell when you go from one to the next, because as you're going, you go from what's obviously shale, small particles, just feels different, looks different. You get into the sandstones and the traditional lion sandstone, the flagstone that everybody likes to use to make walkways and stuff like that and build benches. It's red, it's gritty. It's so much different than this rock right here. And then when we finished up in the Fountain Formation on our hike, we were able to really see some great examples of some conglomerates up at the top of that. So much different depositional environments. So lots of different stuff happening, as we saw in one of the assignments we did. The landscape of Colorado looked different as you moved from different time periods. So what you're going to do is you're going to go ahead and look to try and create some cartoons. And in each one of the images, you're going to have to kind of describe what's going on when you're forming, for example, this shale layer right here. What did Colorado look like? What was the depositional environment across the North American continent, particularly in Colorado, that caused us to have, this shale, this small particle sedimentary rock? So you're going to sketch a picture and try and make sure that your picture depicts what it would have looked like to be able to have this type of sedimentary rock being formed. In addition to the rock part, you're also going to need to have some images of what were the animals and plant life like at that time. And to do that, you're going to think, okay, well, what types of fossils have been discovered in these layers, or at least during that time period, that would be able to allow us to go ahead and date these rocks and know about when this was being formed. So you can go ahead and end this. Well, I'm going to end this, and you're going to go ahead and now go back to the assignment and start to figure out what your cartoons are going to look like. And then there's some summary work as well. So there's two different things that you're going to be turning in, but it's described on the sheet. So thank you very much. Have yourselves a great rest of the day.